Hi there. So in this section, we're going to be looking at complex numbers. I encourage you in Canvas, there is a video that shows you where complex numbers, your imaginary numbers are. And I encourage you to watch maybe the first couple of minutes. I think it's like a 5-minute video, but watch the first couple of minutes of it because at least I think it gives you a nice introduction and visual of what it means to be an imaginary number. Okay. All right, so with that said, looking here in our notes, we're going to have to be simplifying radicals here in a few moments that involve imaginary numbers. So I thought it might be a good opportunity for us to remind ourselves about how do we simplify radicals that we did back on the first day of class. So an example one, I'm going to do A, B, and C with you. Let you pause the video and check yourself by the solution key for D and E. All right, so remember when you're simplifying your radicals, you're always looking for the highest number in your list. And I went ahead and wrote this list up here, but remember, these are your perfect squares. These are numbers that you can take the square root of, 4, 9, 16. And remember, I generated this list for myself, right? 2 squared is 4, 3 squared is 9, 4 squared, 5 squared, 6 squared, 7, 8, 9, 10. I stopped it at 10 squared, but I could keep going. But that's sufficient for our problems here and most problems in this class. All right, so the idea, remember, if you recall, is that you're looking for the highest number in that list that will divide evenly into your number to be able to reduce. So for 48, I'm looking for the highest number in my list there that will divide evenly into 48. Let's say, for example, you don't see the highest one and you say, hey, I know 4 will go into it. Well, let's do that. So if you did 4, then 4 times what gives you 48? 4 times 12. All right, so now the square root of 4 is 2, so it comes outside. 12 stays inside. But now remember, you always ask yourself, is there still a number in your list that will divide evenly into 12? And sure enough, there is, right? 4 will still go into 12. So let's go again. I can rewrite 12 as 4 times 3. So now the square root of 4 is 2 times the 2 that's already on the outside gives me 4 square root of 3. So that's my final answer. Now, I hinted at the beginning, there was a better way to do this problem. Always try to find the highest number in your list. There was a higher number than 4 that would go into 48. You know what? 16. 16 times 3 is 48. Square root of 16 is 4. 4 is on the outside, 3 is on the inside. And we know we can stop because there's not a number in your list here that will divide evenly into 3. So you'll get it. You'll get the same answer either way. I just wanted to remind you that you've got more than one option in case you don't pick the highest. But always ask yourself, at the very end, is there a number in your list that will go into it? If it won't, then you know you've gone far enough. But like here when we had that 12, oh, 4 will still go into it, so we had to keep going. All right, so let's move over to 108. What's the highest number in my list that will divide evenly into 108? So you just start, what you do is you just go in your calculator, 108 divided by 4, 108 divided by 9, and just start dividing. What you're looking for is that when you divide, you don't get a decimal. You want it to be another whole number. So you should find that for 108, that 36 will go into it. 36 times 3. The square root of 36 is 6, and leave the 3. Okay, and remember, you're only trying these numbers because these are the numbers that you can take the square root of. You want to try 2, for example, because you can't take the square root of 2. You want numbers that you can take the square root of. And let's do one more here together. Like I said, square root of 15. Is there a number in your list that will divide evenly into 15? There's not. So this one is already simplified. Okay. All right, so now let's come on down below. Let's consider this function y equals x squared plus 1. So let's first think about, and if you look at the video, this is actually the function that they look at in that video as well. So if we look at this function here, y equals x squared, well, we know the parent function is the parabola, y equals x squared, and we just learned in our last unit that that positive 1 takes that graph and shifts it up 1 unit. So here's my graph. So there's my 1, here's my parabola. I'm going to find the zeros of this function. And if you recall, your zeros were the same as x-intercepts. It was the only difference, though, was that in the way you reported, x-intercepts are written as ordered pairs, but zeros could just be written as the numbers. And if you remember to find those x-intercepts, to find your zeros, you took your function, you set it equal to 0, and solved. Okay, so that's what we want to do here. So if you think about it, then I take x squared plus 1, set it equal to 0, and I'm going to solve it. Let me make this smaller here. So I'm going to solve for x. So I'll subtract 1 from both sides. X squared then equals negative 1. The only way to get x all by itself, take the square root of both sides. We're getting the square root of negative 1. We've talked about before, you cannot take the square root of a negative number, but now we are introducing the idea of imaginary numbers. The square root of negative 1 is defined to be I, and so anytime you take the square root of something, you get plus or minus I. And if you go back and look at your graph, this should make sense to you. Remember, your zeros are your x-intercepts. Does this graph ever cross the x-axis? It doesn't, right? So there aren't any real zeros. There are no real zeros. We can see that from the graph itself, but we also just picked up, oh, yep, we got 2 imaginary zeros. There are, though, 2 imaginary or complex, just synonyms with one another. Complex numbers, imaginary numbers, 2 imaginary or complex zeros. Okay. We'll be leading up to that whenever this degree here is 2 on your function, that'll tell you how many zeros you should have. Okay, so x squared, I should have 2 zeros. All right. Fact down below, an imaginary number I is defined to be I is equal to plus or minus the square root of negative 1. And let's see, from there, I showed a little bit of work that I squared would be equal to the square root of negative 1 times the square root of negative 1. Anytime you take a square root and multiply it times itself, you get what's underneath. So just be negative 1. So I squared is equal to negative 1. All right, so let's come on down to example 2. I'm going to do the top row with you and then let you pause the video and do the bottom row, okay? And the bottom row is really, you should be able to mimic exactly what I did down below, okay? All right, so for this first one, the square root of negative 9, think about how I could rewrite this. Wouldn't it be legal for me to rewrite the square root of negative 9 as negative 1 times 9, right? Negative 9 is the same as negative 1 times 9. So now think about what we just learned. We just learned that the square root of negative 1 is I, and the square root of 9 is 3. So we now have an answer then of 3i. Okay. Here's what I want you to think about though going forward. My final answer here is 3i. Instead of rewriting what I have here in red, think about, we know the square root of normal 9 is 3, but because it's negative, we're going to make it 3i. Okay, because we know that it's got the square root of negative 1 sitting in there, okay? But I wanted to burn that step here in red. But like I said, think about it moving forward. You know the square root of normal 9 is 3, but because it's negative, it'll be 3i. Okay? All right, let's move over to letter B. All right, so letter B, I got the square root of negative 32. This one's not perfect, so I need to think about a number in my list that will divide evenly into 32. So the same list up above. Hopefully agree, 16 will go into it, so I can rewrite that as negative 16 times 2. And notice how that negative on the outside, I just brought it down. Same thing, I'm going to keep bringing it down. The square root of normal 16 is 4, but because it's negative, it'll be 4i. And then I can't take the square root of 2, so that'll be square root of 2 inside there. Me personally, I'm fine with you leaving it in that format. However, MyLab Math is going to want the I kicked to the back, so they're going to want it like this, negative 4 square root of 2, and then put the I at the back. But make sure that I is not underneath the square root. Okay? Again, I'll take either format. Personally, I actually prefer the way that I wrote it to begin with. Okay? All right, let's move over to letter C. In letter C, is there a number in your list that will divide evenly into 31? And hopefully agree. There's not. But you got to take care of the fact that there's a negative underneath that radical. So think about it like how I did in letter A there. I could rewrite that as negative 1 times 31. Square root of negative 1 is I. Square root of 31. So again, I prefer to write it like that, but MyLab Math's going to make you write it with the I at the back. Just again, be sure it's not underneath the square root. I'll take either way though. All right, I'll let you pause the video and you try D, E, and F on your own. All right, so some patterns associated with I down below. I is definitely equal to the square root of negative 1. If you ever forget, in your calculator, I can be found by hitting second in your decimal key. So you have to know that I is square root of negative 1. But for example, if you forget what I squared is, if you hit second in your decimal key and then raise it to the second power, it'll tell you it's negative 1. And then likewise for I cubed, you can second your decimal key, that brings up I. That'll give you negative I. And then I to the fourth, same way. Second, your decimal point brings up I, raise it to the fourth power, that gives you positive 1. So any multiple of 4 will get you a 1, okay? A complex number is always of the form a plus bi. A is the real part, and b is the imaginary part. And that's why up above they make you put that I in the back, okay? We're going to be treating I as a variable when we're performing our operations on the next page. All right, so if you will flip it over. On this page, how about we do, well, we'll just do a couple of these, okay? All right, so I definitely want to do A and B with you. You've got to be sure that you pay close attention to the operations here. So in letter A, it's asking me to add these complex numbers together. Letter B is asking me to subtract. And then C through F are all multiplication, okay? So in letter A, I'm adding. So in these, you're just like adding like terms. So the number parts go together. So 3 plus negative 2 gets you a 1. Add the I parts, the imaginary parts. So negative 2 plus 6, positive 4i. Final answer. And you are putting your answer in the real part plus the imaginary part, okay? Now in letter B over here, because I have the minus sign, I think it's important that you take that, you remember this is a minus sign, this is like a negative 1 that needs to be distributed through. So I would recommend let's burn a step. Negative 17 plus I, and then I'm going to distribute this negative 1 through. So negative 1 times negative 2, positive 2, negative times negative, positive 5i. So then negative 17 plus 2 gives me negative 15. Combine my i's, I plus 5i, that's imaginary 1i, so that gives me 6i. Final answer. Okay. All right, so let's do letter C together. I'll let you try D on your own. That'd be good. All right, so in letter C, we're just multiplying here, so we're going to be foiling. All right, so let me get my pen going. All right, so FOIL, I'll do my first. 1 times negative 2, negative 2. Outside, 1 times negative 6i, minus 6i. Inside, negative I times negative 2, so negative times negative, positive 2i. And then last, negative times negative, positive 6i times I squared. Because remember, like I said, we're treating I like a variable. Okay, so now let's combine like terms. I have negative 2, negative 6 plus 2, that'll give me negative 4i. And then back here at the back, I squared is equal to negative 1. So like I said, I'm just going to show this step here. So then 6 times negative 1, of course, that would give me negative 6. So I have negative 2 minus 4i minus 6. Final answer then, combine like terms one last time. Negative 8 minus 4i. Now here's what I'd like to tell you in terms of, let's simplify a lot of this work that we just did, okay? So you've got to know that I squared is equal to negative 1. And again, if you forget, is in your calculator. Second decimal point will bring up I and raise it to the second power. Here's another way I like to think about it. I squared always changes the sign of your number. So what I like to think about then is I like to go from this step to this step. That I would have brought down my negative 2. I would have combined like terms. Negative 2, negative 6 plus 2 will give me negative 4i. And I squared is going to change the sign of my number because it's equal to negative 1. So I squared is going to make that positive 6 a negative 6. And then lastly, combine like terms and get you negative 8 minus 4i. Okay, so that's what I would recommend kind of moving forward. Okay, like I said, I'm gonna let you try letter D on your own. Maybe pause right now and you try letter D. I'm gonna come down and I'm gonna do E and F with you. Okay, or maybe watch me do work with me and do E and F, and then you go back and do D, for example, and check yourself by the solution key. All right, so let's look at letter D here. Foiling again. So do my first. 2 times 3, 6. Outside, minus 4i. Inside, positive 12i. Last, 4 times negative 2, negative 8. I times I squared. All right, so I'm going to bring down my 6. 12 minus 4, so positive 8i. I squared is going to make that negative 8 positive 8, right? Because I squared is equal to negative 1, so negative 1 times negative 8. And now lastly, combine like terms. 14 plus 8i. Final answer. Okay. I'm going to go over to letter F. Foiling again. Do my first. Negative 2 times negative 2. First, 4. outside. Negative 2 times negative 7, positive 14i. Inside. Negative 2 times 7, minus 14i. Last, 7 times negative 7, so negative 49i times I squared. All right, something a little different happened on this one. What happens to your i's? One's positive, one's negative. They're canceling out, right? So you're left with 4. I squared makes that negative 49 a positive 49. And then final answer then, combine like terms, at 53. Final answer. All right, that last one was a special one. It's referred to as being a conjugate. And if you'll notice what a conjugate is it has the same first term and the same last term. The only difference are the signs in the middle, right? One's positive, one's negative, but otherwise everything else is the same. So that's what makes something a conjugate. And I have that written down here below. For a complex conjugate, if a plus bi is a complex number, then a minus bi is its conjugate. So remember, the only thing that changes is that middle sign. A couple of facts. The product of two complex conjugates will always give you a real number. So that's exactly what you saw happen down here in letter F, okay? That we multiplied two complex conjugates together and we got a whole number. When simplifying quotients, you can't leave I in the denominator. So that's why we need our conjugates, okay? All right, so if we scoot on down to example 5, I'm going to let you try A and B on your own because those are just multiplying, okay? B is foiling. And maybe I'll do A with you because sometimes it's so simple. Sometimes folks look at it and say, I don't know what to do. You're just multiplying the whole numbers together. So 8 times negative 8, negative 64. I times I squared. And then I squared makes that negative 64 positive because it's equal to negative 1. So final answer there. I know you can FOIL on B, so you're good on that one. All right, so let's come down and let's do C and D together. Now then I'll let you try letter E on your own, okay? All right, so like I said up above in that last note is that it's not legal to leave I in the denominator. So in order to get I out of the denominator, you multiply by your complex conjugate. So you multiply the top and the bottom by the conjugate of the denominator. So here I have 5 minus I. So remember, the only sign that changes, the only thing that changes is the sign in the middle. So 5 plus I on top and bottom. Okay. So now up top, we're foiling. So you get 10 plus 2I inside. 15i last. 3i squared. On the bottom, foiling. 25, let's see, plus 5i minus 5i minus I squared. All right, let's keep cleaning up. So let's see, up top I've got 10 plus 17i minus 3. On the bottom, the 5i's cancel out, and I'm left with 25. I squared makes that negative 1, positive 1. Clean up one more time, so I have 7 plus 17i over 26. Again, I'm okay if you leave it like that. MyLab Math, though, is going to want you to break it up between the real part and the imaginary part. So that would be 7 over 26 plus 17 over 26i. Okay, but I'm going to box both of them in because I'm good with both. As far as like when it comes to testing, for those of you that test in class. All right, so moving over to letter D, I am multiplying by my conjugate to get rid of the I in the denominator. So again, the only thing that changes is the sign on the bottom. So I multiply by 3 minus 2i. If you feel good about it, go ahead and pause the video, try it on your own. Then you'll be able to check yourself and be able to see me walk you through it if you need it. And then I'll definitely let you do E on your own. All right, so up top I'm foiling. Doing my first. 3 times 3, 9. Outside, minus 6i. Inside, minus 12i. Last, positive 8i squared. All right, you're foiling on the bottom as well. So you got 9 minus 6i plus 6i minus 4i squared. All right, so let's start cleaning up. I have 9 minus 18i. I squared makes that 8 up top, negative. On the bottom, the 6i's cancel out. I squared makes that negative 4, positive. So that'll give me 1 minus 18i all over 13. If you break it up, then you got 1/13 minus 18 over 13i. I'll box them both in. I'd take either. All right, let you try letter E on your own. I want to make one final note. Let's say, for example, you have gone through the conjugate process and your final answer has landed you here. 14 minus 24i all over 6. None of the examples that I chose had anything where you could reduce, so I just want to make sure you're recognizing as long as all three of these numbers outside have something in common, they can be reduced. And so 6, 24, and 14 can all be reduced by 2. So I'd go through and reduce them all by 2. So divide by 2 is 7, divide by 2 is 12, divide by 2 is 3. So we'd say then 7 minus 12i over 3, or 7/3 minus 12 thirds I, which then you could make that, oh, I could say, well, that's 7/3 minus 4i. Okay, so I just wanted to draw your attention that if you're reducing, you should reduce if you can, and the only time you can reduce is when all three have something in common whenever you're in this format, okay? And so they all had a 2 in common, so I divided them all, and I would have taken this answer, or if we separate it into the real and imaginary part, we can reduce one more time because 12 divided by 3 is 4, or that answer. Okay, so always be on the lookout for any kind of reducing, but it has to be all three from the get-go, or after you break it up, it's possible to just do one and not both. Okay, all right, that finishes this section. Thanks a lot. Bye.